to come. Alright, they may or may not come. Alright. So today we'll be doing acids, bases, and salts. Alright. But of course the topic was so large I have to use it two classes. Alright. And normally this is one class for a topic, but this one is an exception because I want to do the titration stuff next week. Alright, which you have to understand because it's always in the exam. Alright? No, so first definition. So an acid, simple definition for an acid. An acid is a proton donor. That's a basic definition which you can't go wrong to give that definition. Alright? So it's normally a substance which donates a proton. Right? And a proton is basically H plus. Now know that hydrogen would have one electron, one proton. Right? So whenever the hydrogen loses that electron, it now becomes H plus. Alright? And another definition is that it's a substance containing hydrogen which can be replaced directly or indirectly by a metal to form a salt, right? Contain can be replaced Alright, so examples of acid: HCl, H2SO4, H3PO4. This is hydrochloric acid. So these are examples of some acids, right? So as you can see, hydrochloric acid will have one proton, sulfuric acid have two protons, phosphoric acid have three protons, right? So in the same breath, we normally can give use this as one type of classification for a salt, right? With a monobasic, dibasic, or tribasic salts, alright? Good. So hydrochloric acid will be a monobasic salt, so you can react with 1 mole of OH minus. Sulfuric acid is a dibasic, can react with 2 moles of a base, and so phosphoric acid can react with 3 moles of a base. Alright, so you can react with 3 OH minus ions. Alright, so that's how you would use it to balance the equation. Alright, so some of the general properties of acids in aqueous solution. I'm just going to just talk about those stuff, but you can go and read them. So they normally have sour in taste. You can just think of like oranges and lime. Those normally have citric acid. You can know that acid tend to be sour. Alright, they tend to be corrosive, meaning they will rot like metals. They tend to react readily with like different metals and they will rot, right? Important thing in terms of indicator change, they normally turn blue litmus paper red. Because at CSEC level, it's very essential that you know about base and acid in terms of the different indicators that they use, right? And litmus paper is one of the basic one in which you need to know, and it's red in acid and blue in base, litmus paper, right? But they have two types of litmus paper. They can have it in red and they can have it in blue, all right? And the pH scale normally just a scale from 0 to 14 is pH. 7 is normally neutral, right? So everything below 7 is acidic pH. Everything above 7, between 7 and 14 is basic. Alright, and 7 is neutral. Alright? And acids, they conduct electricity in solution. Alright, so if you have a solution of hydrochloric acid, it can actually be used for electrolysis. So the electric current will pass through the solution because it has ions that can be discharged at the electrodes. Alright? Alright, so of acids Alright, so one reactive metals, right? Example, we can go magnesium metal solid plus hydrochloric acid and they normally react to form a salt plus hydrogen gas, right? So the general equation for the reaction with metal is a salt plus hydrogen gas. So this is going to be MgCl2aq plus H2 gas. Alright, so to balance this equation, we would probably put a 2 here. Alright, and that's balanced. Now, looking at this equation on the board, some basics errors that some students may make in exam in the past is like if they are doing like an ionic equation or they are writing magnesium chloride. You see this magnesium chloride, this is not a magnesium atom and a chlorine gas. It's not the case. This Cl2 here is not a gas, it is 2 chloride anion, 2 Cl minus. So in reality this is a Mg2 plus 2 Cl minus. That's what this really is. So this is not Mg and Cl2. You get what I'm saying? So don't go and make mistake like this in the exam. Plus acid produce a salt plus hydrogen. Right? So that's the general equation for that reaction. Clear? So this should actually be at the top, right? 2, acid will react with a base, right? Alright, so acid will give us salt plus water, right? And then quick example of a base, sodium hydroxide. Low sulfuric acid this time, right? Remember, you have to write the physical state in the equation because you're getting marks for the correct formula for the compound, the physical state, and to separate the products, and the arrow to separate the products from the reactants. Alright? This is going to produce Na2SO4 AQ plus H2O liquid. Alright? So we're going to need a 2 here for sure. A 4, and then probably need a 2 here. And that should balance. Alright? So if you notice in this case, this is a dibasic acid, right? So if you can see the mole ratio, it's 2 to 1. So the sodium hydroxide has only 1 mole of hydroxide per formula unit, right? So it will need 2 of the hydroxide ions to react with 1 mole. So 2 moles of hydroxide here to react with 1 mole of sulfuric acid. Clear? Because it ionic wise is the OH minus reacting with the H plus, right? And remember that this H2 here is not hydrogen gas, it's actually 2H plus and SO4 2 minus. So these are the 2 ions which make up the sulfuric acid. Clear? So if you see H2SO4, this is not a hydrogen gas catched in front of the sulfate. It's actually 2 protons. I want you to have those little basic concepts that I say students will make error in an exam. That is not going to look good for the student because they're going to show that you don't understand the basic concept of chemistry. Alright, so next reaction with acid will react with carbonate or hydrogen carbonate. Right? The third reaction of acid. So acids react with, right? So acid plus carbonate produce a salt plus carbon plus water, right? The example of acid is HCl plus magnesium carbonate and react in the solid state. And most of these ionic compound are really solid at room temperature, so we can always just add the acid liquid to the solid, right? But we have to know that all acid is always going to be in aqueous form. Alright? Produce the salt, which would be magnesium chloride, aqueous, plus CO2 plus H2O, liquid, carbon dioxide, and the gas. Right? Balance this equation, the two there, and that should be it. Acids react with hydrogen carbonate, right? Alright, so this is basically a carbonate, like instead of the two protons substituted from the carbonic acid, they just substitute one with like a sodium. Alright? So the hydrogen carbonate again, same thing as above, salt plus CO2 plus water. Alright? We can write out the words here. Right? Example, HCl AQ plus sodium hydrogen carbonate aqueous produce sodium chloride aqueous plus carbon dioxide plus water. Yes. It's balanced in this case, alright? Can make a note of that as well. Alright, next we look at acid anhydrides. So these are compounds that react with water to form an acid. So they are basically similar stuff. It's just that carbonate is technically a different compound from a hydrogen carbonate. But as I said before, both are coming from carbonic acid, H2CO3. If you react that with 1 mole of hydroxide in a titration type equation, you will end up produce the sodium hydrogen carbonate as the product. Alright? And that itself still have a proton that can react. So this would be like an acid salt, we call them. Alright? Now sense. The next thing. Acid anhydride. Anhydride, right? So it's a compound that reacts with water to form an acid, right? Right? So basically all of the non-metal oxides tend to be acid anhydrides, right? Well, some of them are different, but most of them tend to be acid anhydride, right? Example, carbon dioxide gas is a metal anhydride, and when you react it with water, liquid, produce H2CO3. Carbonic acid, right? This is, right? If you look at sulfur dioxide gas, we react it with water, you'll form, or even go, let's keep it like how we used to it. Sulfur trioxide gas will form sulfuric acid. Alright? So, acid anhydrides are basically compounds that will react with water to produce an acid. But they are typically the oxides of nonmetals. Carbon dioxide, sulfur trioxide, nitrogen dioxide. All those nonmetal oxides. They tend to be acidic, but if they are not acid by themselves, they are acid anhydride because they will dissolve in the water to form an acid, right? Or they will react to form an acid. Better yet, it's actually a reaction, alright? So this is not just dissolving, but it's actually reacting, right?